Welcome to our next lesson where we are going to implement support for pagination inside of our REST API. Broadly speaking, there are two types of pagination that you can implement. There is offset-based pagination and then cursor-based pagination. The first one is also known as skip-take pagination, and cursor-based pagination can also be called key-set pagination. It doesn't matter how you end up calling which pagination approach. What I want to focus on is the underlying idea. How do we actually perform the pagination, and what is even the purpose of doing pagination inside of an API? So let's tackle the second question first because it's fundamental to our implementation and why we are doing this, and then we're going to talk about implementation details. We are doing pagination to reduce the number of records that we are transferring over the network. If we are dealing with a collection of resources, let's say the habits, or the daily entries of those habits, and this collection has many records inside, possibly thousands or even millions, it's not very resource efficient to return all of them from our API inside of a single request, which is why we implement pagination. This allows us to fetch a smaller subset of records from our API, represented by a single page of resources, and when we need more records, we can load the next page of resources, and so on until we find the records that we are looking for. Another benefit of pagination is improved performance and reduced load on your server because we are processing less data on the server and we're also transferring less data over the network. Now let's focus on the specifics of these pagination approaches. Offset-based pagination relies on two parameters. The first one is the page, or an offset, and the second is the page size. And with these two parameters, we perform pagination by skipping a given number of rows or resources and then returning the next page of result represented by the page size. Another name for this is skip-take because we are skipping a given number of records and then taking the current page that we are looking for. Cursor-based pagination, on the other hand, is more efficient because it uses an opaque value called a cursor to seek into the last row that we have returned in the previous page. And based on the cursor, we can find the ID of the next resource or next row in the database that we want to return, and we are only going to return the rows after that, representing the next page. Now, the reason this is more efficient is because of how databases work under the hood. I'll discuss this more in the advanced concerns section, where I'm going to show you how to implement cursor-based pagination, and inside of this lesson, I will show you how to implement offset-based pagination. We are back in Visual Studio, and let's continue working on our example in the Habits controller. In the getHabits endpoint, we already implemented support for searching and filtering. We extended that by supporting sorting using the dynamic link library, and now we want to implement support for pagination and returning a subset of the records from our database. The good thing is we were forward thinking from the start, and we added a DTO to represent the response that we'll be returning from this method. So all we have to do now is to somehow figure out how to return just one page of records and include some metadata in the response that's going to describe what we are returning to the client. Now, I will try to make this solution as generic as possible so that we can reuse it throughout our application. Let's start by updating our query parameters. I'll go into the habits query parameter type, and what we need to add here is support for a page and a page size. Let's define the page value, and it can be null, so I'm going to assign it a default value of 1. Then let's also have a page size, and this is going to have a default value of 10. We also want to constrain the page size to some maximum value. This could be a global configuration, or you can define a specific maximum value for each of your endpoints. I leave that up to you. I'll show you an example of just setting a max value inside of our one endpoint. With these two parameters in place, we have all we need to support pagination. So let's go back to the habits controller and let's see what we have to do inside of our endpoint. We'll have to do two different things. The first one will be counting all of the available records in the database that satisfy our search parameters. The second will be extracting only the current page. And for this, we need to send two different queries. So I'm going to extract everything up to the where statements into a queryable. Let's introduce a variable and let's call this the habits query. Then we need to get the total count of records, and this can be an integer or even a long value, and we're going to get the total count by using the count async method. Then we're going to apply sorting to our query, and we're also going to apply the projection to get back a habit DTO. Now before I apply the projection, I want to do my pagination. So I want to skip the current page reduced by 1 because our offset is 0 based, and then we're going to multiply this by the page size. And I realize now that there's probably no need to use nullable types here, so let's omit this, and the default values will make sure that we have provided the required parameters. So I can simplify my query slightly, and after skipping the records that we want to skip, I can say take and then specify the page size. So this will give me back just one page of habits that I want to retrieve from my API. Now let's focus our attention on our response DTO. Let's go into the habits collection DTO, and here I want to expand this with some metadata. And we have two options here: continue adding stuff to the habits collection DTO, or create some general purpose wrapper that's going to represent a pagination response. And it would even be helpful if we standardize this inside of our API. So let's say I define an interface that represents an I collection response. This can be a generic type, and all it has to do is define a list of T, and let's call it data, or another naming convention that you will see is calling this items. Now, in order to implement this inside of my habits collection DTO, I have to rename data to items. And even though this is a breaking change, we don't have any consumers, so this is safe to do, but we are going to discuss how to approach breaking changes when we talk about API versioning in one of our upcoming lessons. So let's say this is my generic abstraction for collection responses. Let's move it into its own file, and let's create a folder that's going to hold these common DTOs inside of my DTOs folder. Now I will take the I collection response and move it inside, and also update the namespace. Where else can we use this? Remember that we had a tag collection response here. This would be a good use case for using the collection response, and all I have to do is rename this to items, update the setter, and I will also have to go into the tags controller and fix the property name here. So now I will close this down. While I'm here, let's also move the tags collection DTO into its own file, and then I will close this down. Let's also do the same for the habits collection DTO and move that into its own file. And let me drop down these folders so that you can get a better view of what I'm working with. I won't be needing the collection response for now, so I will close that, as well as the habit DTO and the habit query parameters. Now, what else do we need in our habits collection DTO to support pagination? And moreover, do we even need a habits collection DTO? What if I define some generic type that can represent all pagination responses? Let's go ahead and do exactly that. I'm going to rename this into a pagination result, and it's going to now become a generic type. I'm going to use this value in the I collection response, and let me also update the items property definition. Then I want to move my pagination result into the common folder and adjust the namespace. We'll have to add a using statement in the habits controller, and here let's specify habit DTO as the pagination result that we are returning. And let me rename this into pagination result. Now let's go back to our pagination result, where I'm going to introduce some metadata. This will be information that we already have, like the page size, the total count that we are getting from our count query, but I can also calculate some values, like the total number of pages, if we have a previous page or a next page of results. And one more thing I want to do here is to define a static method that will allow me to return a pagination result instance. It can be a generic method, accepting an I queryable and a page and page size. And what we need to encapsulate inside is our total